All right, so last set of examples. So here we have x to the 1/2 minus 2, and then 3 times x to the 1/2 plus 2. So remember, our fractional exponents represent a radical. So this really means the same thing as the square root of x minus 2 over 3 times the square root of x plus 2. And we can't have a radical in the denominator, so we're going to have to use our rules for rationalizing a binomial with a radical. So that means that we're going to have to multiply the numerator and denominator by the conjugate, and the conjugate is when we change the sign in front of the radical. So we need to multiply by negative 3 square root of x plus 2 to the numerator and the denominator. So to simplify, we are going to need to FOIL. So we have the square root of x times negative 3 square root of x. So that will be negative 3 square root of x squared. And then the square root of x times 2 is going to be 2 square root of x. And then negative 2 times negative 3 square root of x will be a positive 6 square root of x. Negative 2 times 2 will be a negative 4. And then we also need to FOIL the denominator. So 3 square root of x times negative 3 square root of x is negative 9 square root of x squared. And then, so we did that one. So 3 square root of x times 2 will be a positive 6 square root of x. And then the middle ones will give us a negative 6 square root of x. And 2 times 2 is 4. So now we're just simplifying. So this is really the same thing as x, and then we can combine the middle ones together. So in the numerator, we're going to have negative 3x, and then I'm going to write minus 4 next. And then when we combine those, 2 plus 6 is 8. So plus 8 square root of x over. And again, when we simplify, our middle terms cancel. And then this will be the same thing as negative 9x. So negative 9x plus 4. So this is going to be our final simplified answer for that problem. Okay? And this was to number 22. All right, 23 is going to be the same idea. So if it's easier for you, we can switch to radical form. So this really means the square root of y plus 2 over negative square root of y plus 1. So again, we need to multiply by the conjugate of the denominator. So that's going to be a positive, so we change the sign in front of the radical. So positive square root of y plus 1. And then we are going to need to FOIL. So square root of y times square root of y is the square root of y squared. Square root of y times 1 will be the square root of y. 2 times the square root of y is 2 square root of y. And 2 times 1 is 2 over. Negative square root of y times square root of y will be negative square root of y squared. Negative square root of y times 1 will be negative square root of y. 1 times the square root of y is a positive square root of y. And 1 times 1 is 1. So again, simplifying, this is just the same as y, and then this will be a negative y. So if we combine like terms, we're going to have y plus 2 in the numerator. And then square, so this is a 1, so 1 plus 2 will give us 3 square root of y over. And again, our middle terms are going to cancel, so we're going to have negative y plus 1 in the denominator. So this will be our final answer for problem 23. All right, 24. So again, I'm actually going to switch to radical form. So this is really the 5th root of x over the 5th root of y squared. So we just need to rationalize. So that means, I'm going to rewrite this here. So we have the 5th root of x and then the 5th root of y squared. So we need to create a perfect fifth when we rationalize. So we're going to multiply by the 5th root of y cubed to the numerator and the denominator. So since these are the same radical, that means that we'll have the 5th root of xy cubed over, and then when we multiply these two together, This will give us the fifth root of y to the fifth. So 5 divided by 5 is 1, so we are left with just a y in the denominator. So this will be our final simplified answer for problem 24. And that is also going to conclude this session.